On behalf of the Global Independent VMUG organization, I'd like to welcome you to today's webcast, Next Generation Hyperconvergence with Hitachi, presented by Dinesh Singh, Solutions Marketing Manager at HDS, and John Nicholson, Senior Technical Marketing Manager at VMware. Before we get started, I would like to thank you for participating in today's webcast and for your continued participation in the VMUG program. Just as a reminder, VMUG offers a number of benefits to our members, including complimentary local VMUG meetings and full-day conferences taking place around the world, our monthly e-newsletter VMUG Voice, access to the VMUG website at vmug.com, educational webcasts like these, and the ability to subscribe to VMUG Advantage, a benefits package only available to our VMUG members that provides discounts on training, exams, licenses, eval experience, and VMworld. Make sure to take advantage of everything VMUG has to offer. Moving on, I have 3 housekeeping items. First, we are recording today's session and will make the recording available for on-demand. You can expect to receive a follow-up email directing you to the recording. Second, we will be holding a Q&A session throughout the presentation. All questions need to be entered into the Q&A widget window to ensure our speakers receive and see them. They will be addressed one by one accordingly. And third, there will be a short online evaluation that pops up when you leave the webcast. Please make sure to take a minute to let us know what you thought of today's session and what you'd like to see moving forward. And with that, I'd like to hand it over to our speakers. Please go ahead.
Thanks, Karen. Good morning, good afternoon, everyone. This is Dinesh, Solutions Marketing Manager with Hitachi Data System. I manage outbound marketing for Hitachi Hyper-converged solution. Today with us, we have John Nicholson from VMware. John, you want to introduce yourself?
Yeah, thank you, Dinesh. My name is John Nicholson. I'm a Senior Technical Marketing Manager at VMware. I'm focused on vSAN, and I'm kind of the core technologist in that regard. I own the vSAN network and design and sizing guide, so any questions you have about vSAN, which is obviously some of the secret technology sauce here behind the UCP HC, feel free to put those in the Q&A chat wizard below.
Thanks, John. We also have with us David Shu. He's a Senior Product Manager with HDS. He leads the roadmap and solutions integration for UCP HC, and he works closely with John and his team. So today in the session, we will talk about some of the industry trends and what are some of the problems that hyperconverged solutions solve. Then we will dig a bit deeper about UCP HC and why it is a good solution, right solution for your data center and remote branch use cases. To just set the context today, as organizations across the industries are moving to enable digital transformation in their organization. Everybody in every organization is under pressure to perform, either from their anxious boards or from digital disruptor, which could be Uber or which could be Airbnb or any other analogous player in your own respective industry. And CEOs have 3 clear tasks at hand. One is to innovate faster than the competition, to sweat their assets, and manage risk to remain viable and credible in the industry. And in my experience, I have never seen IT playing a more important and essential role in enabling business strategy than today. In today's time, to succeed in their digital enterprise, they have to play a role of knowledge advisor, data broker, and business innovator all at once. For digital transformation as a business strategy to succeed, time to market is a critical element. And traditionally, IT has supported business with infrastructure. If I have to plot it in the continuum between choice and time to market, they would be do-it-yourself, DIY, converged, and hyper-converged. In do-it-yourself, you procured the best of the breed components, integrated, did testing, all by your own. Converged infrastructure, the design which came in the market a few years back, it combined compute network and storage elements together, and it abstracted functionality to be leveraged by a common management tool. That was pretty neat, but it didn't tightly integrate storage, and it still needed the storage specialist to manage storage and also networking. But the evolution of hyperconverged, which is more further evolved form of converged, it not only brought together different elements together, but it collapsed them all together. In the process, it addressed the latency issue between compute and the storage node because it brought a CPU and the storage close by, nearby, and providing data locality. So in DIY, you had choice, but you had to do a lot of work on your own. You need to have specialist skills to integrate, to tune, to get right performance. On the other end of the continuum, hyperconverged, they are ready to deploy out of the box. You can provision VMs within minutes with UCP HC. So that's kind of how it's playing out in the market. Some of the challenges which we had with three-tier IT infrastructure, it was really expensive to procure and operate. And in the process, you were tying in your capital in infrastructure that you may not leverage for months and years to come. That means you are tying in your capex in the underutilized resources. You still had to invest weeks and months of time in integration, testing, performance tuning to get the right performance that vendors had advertised. And if you had any problem, then fault identification and troubleshooting, that's a real pain. I mean, I need not dwell into that. To manage different components, you still need skilled manpower. If you had data protection, backup recovery, you had to learn third-party management tools. Then integration is a pain. And despite all of that, sometimes getting the right optimized performance for application is still a challenge. Hyperconverged solutions mitigate these issues mostly. It allows you to improve IT agility, to grow your infrastructure in line with business demands. And it also allows vSphere admin or any generalist to deploy, manage, and operate your IT environment. In this slide, we wanted to talk about the journey of hyperconverged, how it evolved. John, you want to take the slide?
Yes, let me take over here. So when we look over the kind of the journey of hyperconvergence, we had early HCI, and it promised us a lot of great benefits. It lowered the cost of acquisition. As we were looking to buy infrastructure, we didn't have to go out and build a fiber channel fabric or make a large upfront, I guess, for storage controllers or things like that. And this really helped us get our foot in the door for a data center build out. We also got a really great dynamic scaling. So as we wanted to add compute and storage, we just add another nodes. It got rid of the traditional forklift type replacement. The third piece and great benefit was simplified management. We no longer necessarily had to have separate views for fabric and storage and for the hypervisor itself in terms of that. There were some challenges, though, when we looked to the early days of HCI, is that while it did fulfill the expectation of everything within its realm could be managed, it still couldn't manage external storage. And I'm not going to stand here today and say the only thing that you'll ever have for storage in your data center is hyperconverged. You'll still have traditional arrays, and you need a way to extend that management. The other thing is, from an efficiency of operations, you still had it as its own silo, and so you still were managing your existing environment and managing this separate. And from an efficiency also of performance and capabilities, some of the early HCI would use a lot of CPU. The various virtual machine-based systems could use up to half of your compute. So you were paying a lot extra for your hardware. It wasn't necessarily as efficient. And as you scaled early HCI, performance challenges arose, network in terms of scaling it out and things like that. So really, HCI was often pushed as kind of a tier 2 or a VDI play. And it was really often based around hybrid type architectures or designs, which were good for smaller working sets, but as you got to larger working sets, you kind of would fall off and move back to traditional storage. And then the last real missing piece was policy-based governance. Really, as we move forward towards automation and digital transformation, we want to make sure that we can automate our environment. And if the APIs for the HCI environment are completely different from the APIs in the rest of your infrastructure, and its policy management interface is isolated only to policies within its sphere, it really, again, is just another island. You've basically dropped a mainframe, for better or for worse, in the middle of your data center. Now, when we look at next generation HCI, we're able to break down management silos, and we'll get more to this later, talking about having policies that extend not only for HCI, but also for the rest of your environment. From a management plane perspective, we're able to use the same management interface to manage your hypervisor as well as your HCI storage. From a performance and capability, it's next generation HCI is built into the actual hypervisor, and this gives you very efficient, very low CPU and compute overheads. And as we scale from a performance standpoint, next generation HCI can push into the millions of IOPS and deliver next generation availability features, things like active stretch clustering and fault domains. So that way our data can be aligned with the design of our infrastructure rather than we have to change our data center, our infrastructure, to match how we want to build our storage and our compute layer.
Thanks, John. HDS and VMware launched a next-generation hyperconverged solution, Hitachi Unified Compute Platform HC. We also call it UCP HC, as you already heard, in June of 2016, a few months back. And we have seen rapid adoption of this solution, and we would definitely double-click on why across the geos, across the use cases, and across business segments. To introduce UCP HC, it's a next generation HCI solution that tightly integrates compute, storage, hypervisor, vSphere specific. It is available only for vSphere. That talks about great partnership between HDS and VMware, and a host of data services to deliver next generation data center. It leverages all elements of software-defined data center, compute virtualization, which John and team have developed over the years, software-defined storage, and also software-defined network to improve NSX, to improve agility and manageability of your IT infrastructure. With UCP HC, you can begin really small with just 2 nodes, and you can grow as your business requires in the increment of 1 nodes. And in one cluster, you can scale up to 64 nodes, and you can go beyond that. You can manage multiple UCP HC clusters of 64 nodes from single VMware vCenter instance. That's pretty powerful. And UCP HC, as I said, is purpose-built for VMware, and it's optimized, tuned to perform best for VMware. It is available only for vSphere hypervisor. And one point I would like to note here to mention that it's not just another vSAN-ready node wherein you layer vSAN on a piece of hardware. It's a purpose-built appliance, 2U4 node or 2U1 node that comes with the factory-loaded vSphere and a host of VMware software. We have a partnership at R&D and engineering level with VMware, wherein we constantly engage. We have a team of engineers who engage and develop solutions for different real-world use cases. And you could find out more about it on hds.com, on vmware.com. And last, enterprise ready today for performance, availability, efficiency, and that ties nicely with policy-based management framework that we're gonna take up in a few minutes. It's enterprise ready today. If you are considering a hyper-converged solution for use case, and if vSphere is hypervisor, which most of the customer use, around 80% or more, if I have to quote biggest IT analyst, you should definitely consider UCP HC. It is tightly integrated with vSphere management stack software. It leverages virtual SAN or vSAN for data management and a host of data services. vSAN has the largest hyperconverged footprint in the industry. It's the fastest growing HCI solution, and it has been deployed across the industry, across the segment on a variety of use cases. And UCP HC is the right platform for your data center and also for remote branch use cases. Branches which really require a low cost, small footprint, and low maintenance kind of setup, UCP HC is appropriate for that. Or for data center wherein you require really scalable performance, enterprise availability, stretch cluster plus less than 5-minute RPO, UCP HC can be a right platform for your applications. UCP HC and vSAN Both were designed keeping generalist in consideration, and in case here in case vSphere admin, you can perform pretty much all the functions from your familiar vCenter screen. You will never have to leave, a vSphere web client to perform any functions. And another last thing which John also mentioned, UCP HC integrates with your existing setup. There is no new learning curve involved. You have developed years and decades of expertise around VMware tools, around vCenter, around Site Recovery Manager, around VDI Operations Manager, and you can continue to build and leverage your skill set to operate and manage UCP HC. A look into what we have right now. You have a flexibility of configuration to choose what fits your business needs the best. V240 is a 2U 4-node hybrid appliance for general purpose applications. If you are looking for large capacity hybrid appliance, V210 is the right choice. If you have tier 1 applications that require high IOP and sub-millisecond latency, V240F is the right platform, is the right solution. That delivers good combination of compute and storage, and that scales up to 12 terabyte of usable capacity per node. And if you have a use case which requires large storage capacity, maybe not so much of compute for applications, read-heavy applications, it could be analytics, it could be some of the OLTP application, V210F is the solution. And in single node, you can scale up to 26 terabyte storage capacity per node, adjusted for RAID 6 and space efficiency technologies. All of these solutions come with built-in and optimized data protection solutions, and plus next generation automation and orchestration capabilities that we would be covering in a few minutes. Double-clicking on configurations, UCP HC leverages Intel Xeon processors, Broadwell processors for all of its solutions. 2 Intel Xeon processors per node. You have an option of 8, 10, or 14 cores. Within next 4 to 6 weeks, which is around mid of January, you will have a 22-core CPU available. On storage, you have an option of 800 GB or 1.2 terabyte capacity. In the same time frame, which is mid of January, we are going to make available larger capacity drive, which would be 1.92 terabyte and 3.84 terabyte. That means in one node you will have a raw capacity of around 46 terabyte. That's pretty good. On networking, you have flexibility to choose between 10 gig and 40 gigabit Ethernet switch. You can deploy any network switch, from either Brocade, Cisco, or Arista, as long as they are vSAN supported. It's your choice. Total flexibility you got there. On memory, you have for hybrid 32 gigabyte to 512 gigabyte range. On all flash, it's slightly high, 32 gigabyte to 700 gigabyte. And in the same time frame, these memory limits would be doubled. Wanted to talk something about Hardware Element Manager, which is UCP Advisor. It sets a lifecycle management for entire UCP HC appliance. It's a vCenter plugin that can be managed from your vCenter console. Using this, you can upgrade firmware of computer network. You can manage cycling, and you can manage inventory. It also gives you visibility into networking fabric, and you can do VLAN synchronization between virtual and physical switches. It also helps you rapid troubleshooting and root cause analysis with log insight and analysis of compute and networking logs. And UCP Advisor also gives you access to high track monitoring capabilities, that is support capabilities that allows 24/7 monitoring and troubleshooting of UCP HC environment. We have a slide later that I will cover. While designing UCP Advisor, we had one aim in mind to provide you a single pane of glass experience for all of Hitachi infrastructure solution, whether you are using a VSP storage, VSP-G or VSP-F all-flash, or whether it's converged solution, UCP, or whether it's UCP HC hyper-converged solution. John, in your experience, do you see the utility of UCP Advisor? For customers who have a variety of deployment in your data center. It could be converged or hyper-converged. What's your view? You have seen multiple deployments.
So this is a question I get a lot, is customers are looking for end-to-end lifecycle management. They're looking for end-to-end visibility. They don't want HCI to be another silo. And having that unified visibility is critical, because when you're running business critical apps on this infrastructure and someone says, hey, this is slow, or what's going on, you need to be able to, monitor, remediate, manage the entire stack, because holistically, that's what people consume is the outcome of the weakest leak.
Absolutely. Thank you, John. And UCP HC has a tight integration across VMware software stack, a vCenter server that is used to perform 100% functions on UCP HC. vRealize orchestrator to automate your routine IT task via workflows. You get some built-in workflows for compute and network. vRealize operations for monitoring and remediation, and also for capacity optimization. vRealize log insight for log analysis, predictive analytics, and some of the root cause analysis troubleshooting. vRealize automation for delivering self-service role-based private and public cloud. I think this is one of my favorite slides because it actually addresses some of the concerns which I hear about availability. And so UCP HC and vSAN, they're designed to deliver a hyper-converged solution that would be continuously available and accessible and provide accessibility to data, regardless of hardware and software failure. And what it does, it introduces a new concept called failure domain. And it is used to mitigate any downtime and give you 100% uptime regardless of any hardware failure. It could be host failure, it could be disk failure, it could be top of the rack failure, top of the rack switch failure, it could be rack failure, or it could be a site failure. And it is nicely integrated with policy-based management framework that allows the VM components or data to be spread across multiple hosts. And that is done much more efficiently than what you would receive using a traditional way of storage. And it allows you to have 6/9 availability for a fraction of cost of what you would be spending otherwise to get that kind of availability. And with UCP HC, you can perform host maintenance without bringing live VM down. As I said, you can deliver the availability through policies per VM as per your application need. Now, John will drill down on availability, how it's delivering and how it's enabling high availability on UCP HC cluster.
All right, so I want to drill into kind of what vSAN is under the hood real quick. And one thing to understand is that vSAN is a distributed object system. So you take your components, you take your VMDKs, your virtual hard drives, and it's going to split them out across the cluster. And we've got a couple different constructs to kind of describe how that is. So one is what we have is known as fault domains. And by default, they're a host, but you could also set a fault domain to be something like a cabinet or a pod within a data center. And what this lets you do is make sure that your data is distributed or mirrored in such a way so that if you lost not just a host, but an entire cabinet or an entire pod within a data center, there would be copies of that data still accessible and available, and VMware HA would be able to fire off and reboot that VM or maintain availability if the VM was not directly impacted. Now, you can tolerate, we've got different amounts of these we can tolerate. So we could, start with just the ability to tolerate the loss of one cabinet, or even more depending on how large a cluster and how we span this out. And what drives our policy decisions from an availability standpoint is a concept known as failures to tolerate. And a failure to tolerate can be anything as granular as a single drive failing, or it can be something as large as an entire host failing. Now the default is failure to tolerate of 1, and this can be accomplished either using RAID 1 or if you're all flash or RAID 5. But this can also be extended to 2 or 3, so we could even do multi-way mirroring or a distributed RAID 6 on all flash. And this is going to give you a lot better availability. So when we combine these together, we've got a great story in terms of availability. But one other question that comes up is, what about if I want to span my cluster across data centers? And so vSAN actually supports a stretched cluster. And one thing to note is this is a true active stretched cluster. So you can vMotion a VM back and forth. So if you've got a planned maintenance event, or if you've got early warning of an outage coming, or things like that, you've lost, you're on generators, you can go ahead and vMotion. And we've got a third site with a witness that provides quorum for this. And the witness is just a small either virtual machine or a host. And this allows you to have a true RPO of 0, as well as a fully automated failover. There's no manual having to promote containers or LUNs to be active at the second site. And this can actually scale down to be as small as just 2 hosts, 1 at each side with a witness at the third, as well as scale up to quite a bit more. Now kind of how we combine this together to kind of a busy slide here is from a local site. We can either use fault domains, or we can use, if we've got low latency, high bandwidth between 2 sites, we can do a stretched cluster. So we can have incredible resiliency with an RPO of 0, but we want to stretch farther. So maybe we're stretching from New York City over to Jersey. We've got our stretched cluster, but we also want to be able to tolerate loss of the entire region. And for that, we have vSphere replication, which vSAN can deliver as low as a 5-minute RPO. And that's a true RPO, not a take snap then wait for 5 minutes RPO. As well as we can also automate that actual migration and that failover using what's known as Site Recovery Manager. And Site Recovery Manager isn't just something that coordinates rebooting of VMs and maybe some IP changes, but it's actually a true orchestration platform that allows you to test in a seamless, non-disruptive, automated way your DR. If today your DR test requires that you schedule downtime or do it on a weekend, you really should be looking at deploying SRM, because this will give you the ability to do a full automated, runbook type engagement. And not only for vSAN, SRM also will work with your existing G series as well as your HNAS series in your environment. So you've got one story for all of your storage here from an availability standpoint. And looking kind of double-clicking into the storage-based policy management, as you can see here, we've got different policies. And the granularity, it's not just a virtual machine, but we can apply these policies to individual VMDKs or individual virtual disks. So if we had a SQL VM, we could apply a RAID 5 policy to the database, a RAID 1 policy to the logs. We could set, if it's a hybrid environment, we could set different cache reservations, or maybe we want to tweak performance. If we want to reserve capacity, by default vSAN is 10, but if we want to reserve capacity, you can do all of that, and you can programmatically deploy these policies. We can do it either with Orchestrator. We've got integration with things like OpenStack to be able to call those policies. And really our goal, or our plan, or our evil plan, if you want to call it that, is to provide a common management framework. And this extends not only from virtual SAN, but this is the same policy engine used for virtual volumes. And so when we actually look at how we apply this just to the UI, it's just a couple clicks. And one thing to note is it's actually going and changing when you change a policy, how the data is aligned underneath that virtual machine or that VMDK. And when those changes are complete, we get a compliant state. Now, if a host or a drive is lost, we're actually alerted that we're out of compliance. So there's no opportunity for miscommunication between the storage admin and the VM admin to understand that the VM has the capabilities, the policies, actually with our newest release of vSphere, even encryption, the data services that we're expecting. And one thing to note how this also extends is this is the exact same framework, not only internally for vSAN, but also externally for vVols. Dinesh, you want to take it back?
Yep, absolutely. One moment. Yeah, so just to complete the story, what John said, this is the benefit of dealing with end-to-end solutions provider like HDS. You get the common policy-based management framework, whether you are using Hyperconverged, UCP HC, or whether you are using storage, external storage. It could be VSPG or VSPF. And I got one good question on the chat box. Which CPU UCP HC uses for data management function? So it uses internal CPUs for data management functions. What sets it apart from some of the other HCI implementation, as John also covered in the beginning, is vSAN is baked inside the vSphere hypervisor. So the CPU tax is much less than 10%. We have never seen an instance wherein more than 10, it goes beyond 10%. Wherein some of the other HCI architecture, which are based on external CVM-based management, wherein you have a new object to manage placement and deliver data services, your CPU could get consumed as high as 40%, 45%. So that's the benefit of using UCP HC with vSAN. Great question. To continue the session, HDS HDS offers hyperconverged and converged and optimized converged solution for a variety of use cases. UCP HC is what we're speaking about. UCP 2000, 4000E, and 4000 are Intel Xeon-based converged infrastructure that leverage external storage. UCP 6000 is a workload optimized converged solution for SAP HANA and the Oracle database. John, you want to walk us through some of the efficiency technologies that customers get from UCP HC?
Sure, more than happy to. So introduced in vSAN 6.2, we introduced both deduplication and compression. And when we looked at this feature at the end of last year, they were implementing it. They looked at the different ways they could implement it. They could have tried to optimize it for hybrid, but they would have had to make a lot of compromises in terms of compute overheads. They wouldn't have been very granular. And when you look at a lot of the data reduction systems that focus on hybrid, there's a lot of compromises, and we really didn't like compromise. And we saw a shift from really towards all flash. As we looked at the capabilities of flash drives, the performance was really exciting. And so we really optimized this around a flash story. And one thing we did is from a block size, we chose an incredibly granular block size to pattern match a 4 kilobyte block, which 8 kilobyte or 16 or even larger is very common in the industry. And what this means is you get very efficient deduplication. The other thing we also chose was to do compression and do it at the same time as the deduplication. And from a kind of an I/O flow, how this goes is as the data is written to the host, we have 2 tiers of flash in the all-flash environment. We've got a write buffer, and that data is immediately acknowledged, so there's no latency added by this functionality for writes. Now, as that data destages to the lower cost capacity or lower endurance tier, that's where that process is done. So this is a inline type process. So we're not doing any type of post-process. There's no schedules to manage. There's no worries about fragmentation on the back end or other performance problems that this can introduce. And as that data is copied into memory to migrate, the first thing we run is we run a hash calculation. We say, is this data unique? If the data is not unique, we just write a pointer and we're done. If the data is unique, we're going to try to compress it. And we're going to use industry standard LZ4 very fast. Our friends at Intel make sure LZ4 and hash are very fast. And if that data compresses well, we're going to save it compressed. If it doesn't compress well, let's see, we only get 3.5 kilobytes out of 4, we're just going to write it fully hydrated so we don't cause fragmentation issues, as well as also we don't want to waste compute rehydrating compressed data that doesn't compress well. We're also not deduplicating data that has a very short lifespan. So if data lands in that write buffer and it's quickly overridden, we're not going to waste compute running dedupe and compression. And all of these ways of avoiding wasting compute allow this feature to be turned on and really only have about an extra 5% compute overhead, which is pretty amazing. And so rather than focus on having different schedules or granularity of saying these VMs are this and these are this, we wanted this just to be something that you turn on. It's very easy. And so when you have your all-flash vSAN, you're setting it up. This is just one extra checkbox that you check, and you're done. And really, for the majority of customers who aren't pushing the extremes of OLTP writes or things like that, they're going to turn this on and they're going to be very happy with the results. Some other space efficiency features that were introduced also for vSAN and are available here is RAID 5 and RAID 6. And so from a RAID 5 perspective, we're going to take that object and split it up into 4 components. We're going to use a 3+1 construct. And so previously, while we always had to use mirroring, this allows us, instead of a 20 gigabyte VMDK consuming 40 gigabytes, it would only consume 27 gigabytes. And note, the RAID 5 and RAID 6 type policy protection can be enabled on a granular basis. So you can set this on an individual VMDK or an individual VM. And unlike deduplication and compression, this is space savings that you really can bank on. You can count on this existing. RAID 6, which has a 6-host minimum, uses a 4+2 construct. And so previously with RAID 1 mirroring, we'd have to make 3 copies to be able to tolerate the failure of 2 hosts. In this environment, we're instead doing, instead of that 20 gigabyte using 60 gigabytes, it now will only use 30 gigabytes. And so for larger clusters and all flash, this is a really great way to have an incredible amount of protection without necessarily having to have a huge amount of overhead. Dinesh, you want to take it back?
Yep. So this slide talks about not just the primary use cases for UCP HC, but it also reflects the use cases for which it's being deployed for customers. So we have seen UCP HC being used for deployment of SAP CRM, for SQL Server, for branch office use case, for test and dev, for Horizon View, of course, for vRealize automation-based private cloud. And a couple of customer success story I would like to share. They are incognito at this point of time, but very soon you will find them on HDS.com. One Switzerland-based customer, he was evaluating a hyper-converged solution for a tier 1 application, SQL Server and Exchange. And they evaluated 3 platforms, UCP HC and a couple more, on performance and also on data loss for stress cluster configuration. And after a month of continuous testing, stress testing, they chose UCP HC, and it's live, and we never had any. I mean, it's pretty new, but customer is satisfied. Another instance I will talk about a North America, Minnesota-based customer, and customer had to launch a new branch. It's a financial services customer, and branch had to go live in relatively very short duration. And customer decided to go with UCP HC primarily because of faster time to market. The time, the lead time that he used to take before Hyperconverged and UCP HC, that was cut down significantly. And customer is running his branch office on UCP HC V240 2U4 node Hyperconverged solution. One question I saw in the chat box is UCP HC ready for VDI for developer environment? Yes, it is. In fact, we have 2 slides on VDI, and HDS and VMware has joined reference architecture to deploy VDI either in traditional way, wherein you deploy and manage VDI application on premises, or the newer way, which is you deploy VDI on UCP HC in your data center on premises, so you have control of data and control of governance, but you can manage through cloud, which is known as Horizon Air Hybrid Mode or Project Enzo. So I will discuss in next couple of slides. Another interesting question is what is the CPU utilization during dedupe and compression? John, you wanted to talk about in your experience, in different workload now?
So in terms of CPU overhead for, you said compression and deduplication is the question?
Yeah, that's right. For different workloads.
So if it's a read-heavy workload, general mixed use, it's only going to be 1 or 2%. When you're going to see it go up closer to that 5% is when you've got a write-heavy workload. If you're sitting there running OLTP, TPARC-C benchmarks or something, then that's where it's going to push up higher. I ran a VDI environment where my CPU overhead for vSAN was only about 2.5%. for our steady state run operations. It was only during recomposed windows where it would spike a little higher. But we do have some white papers out there. There's a vSAN 6.2 Horizon 7 white paper that actually show individual overheads for all different features. So that you might check that out.
Right. And in terms of space efficiency ratio, it depends largely on the kind of workload, as John said. And in lab test, we have seen the storage requirement cut down up to 7x for some environment. So it actually depends on your workload profile.
Yeah, I always recommend people check out their, because it's just standard LZ4 compression and a SHA-1 4K hash. Let's say you have backup software today that's already doing some type of compression or deduplication. Check out your reports there and see what type of compression you're getting there. As well as there's actually a space efficiencies guide. If you Google vSAN space efficiencies guide, it's at storagehub.vmware.com. It actually goes into specific types of data sets and says, okay, you're going to get better space savings using this data reduction set, or for these types of workloads, and generally we'll see better compression, or these will see better. You're probably just better off using RAID 5, RAID 6 instead, that type of thing.
Right. So I got another interesting question. What does UCP stand for in UCP HC? It is Unified Compute Platform. It is a UCP family of hyper-converged and converged solution, but UCP HC makes use of internal storage-based, software-defined storage. It creates a cluster of internal server-attached storage. Good question. Talking about VDI use case, as I said, in traditional way of delivering IT for VDI had some challenges. The SAN environment used to become a bottleneck in some scenarios if you are deploying a large number of virtual desktops and typically during morning boot storm or afternoon scan storm. UCP HC solves these problems with excellent scalable performance. And to speak of performance numbers, we conducted tests in the labs, and UCP HC V240F 64 node cluster scales up to 6 million IOPS, with 100,000 IOPS per node. So that's pretty good to handle boot storm and scan storm issues. And with UCP HC, you can really begin small with just 2-node cluster. You can use cross-connect cable to connect these two nodes. You don't need top-of-the-rack switch. And you can just begin with, say, $25,000, $30,000 solutions, which for either VDI or for Robo. So if you are beginning with, say, 500 desktop or 1,000 desktops, you can begin with 2 or 3 nodes. And as you add more manpower, more people in your company, you can grow your environment linearly. UCP HC with its robust data efficiency technologies, it brings down the cost of ownership per desktop, and it improves ROI. That makes it quite easy. And with the HDS, you not only get the native data production, which John spoke about, you also get optimized DR with integration of HDI, which is Hitachi Data Ingester, which Hitachi Data Ingester is actually a solution that flushes the data from remote site to central site in an automated fashion. And with the integration of HCP or Hitachi Content Platform, which is a bottomless object storage repository, with this you get an option to roll back to any point in time data copy. And if you have a roaming user, mobile user, they can move across sites while their user data, their profile, everything is stored in central location at Hitachi Content Platform. It's a pretty powerful solution. And not just the product and solution and technology, we at HDS have long experience in deploying a really large environment in multiple 10,000 plus users in organizations, and also up to 100,000 desktops. So if you decide to go with HDS, if you consider HDS, look at the solution, look at the strength of technology, but also we have a rich experience in our services team that would be very useful when you move toward VDI environment. Talking about second way of delivering Horizon VDI is Horizon Air Hybrid Mode, or some of you may have known it as Project Enzo. In this type of delivering Horizon VDI, you deploy Horizon virtual desktops on UCP HC in your data center. So you have control over data, you have control over security, your IT policies, but you manage from cloud, from either vCloud Air or any of the other supported cloud network. It could be AWS or it could be tomorrow IBM software. What it does is you only take care of your applications, your virtual desktop images. You don't have to deal with underlying infrastructure. So think of it, you're moving away from infrastructure management and you are moving toward your application management. So who takes care of Horizon View installation, updates, patching? VMware does. So you don't have to ever deal with software maintenance, the pre-installation testing, weeks of testing. You can roll it out pretty quickly. You can scale up pretty quickly. You don't have to be bothered about new version release, updates, patches. VMware does everything on the background. And it uses next generation technologies like instant clone and app volumes to really create new virtual desktops and push applications live in a matter of milliseconds when you open your device. So you have the persistent desktop experience without provisioning for infrastructure at the backend for persistent desktop. It's a pretty powerful solution. We are doing multiple POCs with customers, and customers have shown significant interest in this solution. John, you want to take it up about Robo use case?
Yeah, so remote office, branch office is a conversation I keep having regarding virtual SAN deployments. And the reason why is traditionally customers had, lots of sites, but the problem is particularly the smaller sites, you want high availability, but going and procuring and deploying a storage array and a full HA cluster just for a file print DC and one or two applications, it's really hard to make that cost justification for that availability. And so what's really great with virtual SAN is from a licensing perspective, there's different options in terms of you can actually license it on a per VM basis as well as VMware vSphere. So as you start scaling down these sites, there's a lot more flexibility. The other thing is also you've got a great little starter package. You can start as small as 2 nodes with a direct connect option, and you can expand up and add 3rd, 4th, 5th nodes as you need. So you don't have to try to predict the future about how much resources you'll need at a given site. Now, Hitachi's got a great story here in terms of that. You've got at the data center here, we see the HCP, the big Hitachi content platform, which is their object storage system, and that can handle all kinds of unstructured data. But on the branch sides, you often want access to data in the form of file systems for things like home shares or just departmental shares and things like that. So Hitachi has a virtual machine, HDI, Hitachi Data Ingester, which acts as basically a bottomless NAS, a bottomless file server that's continuously streaming back all data that's written back to the primary site and checkpointing that. So that way, if a local site disappears in fire, flood, or blood, or flames, that data is carefully protected back within the HCP instances and be reconstructed. There's also some really cool capabilities in terms of being able to roam home folders and things across sites. And combined with the UCP HC series, you can deliver all of these great edge services at a really low cost point and have something that's very turnkey in terms of being able to roll out. The conversations I have with customers often start with maybe a dozen sites, but they quickly go into the hundreds, and I even have some conversations in the thousands of sites. So vSAN, not only does it scale up for the customers with over a petabyte in a cluster and millions of IOPS, but it also scales down to those little bitty sites that have 3 VMs, but you really want them protected.
Nice.
Dinesh?
So we spoke about UCP HC solutions, and I'm sure you would also be interested in learning about some of the best-in-class HDS support for UCP HC. We are global OEM partner of VMware, and we provide a single point of support for entire appliance, for hardware and software. You don't have to open 2 tickets, which could be case for many other HCI solutions, one with HDS, one with VMware. No, you just open 1 ticket with HDS if you need support, and HDS has hundreds of VCP, VCAPs in support team, and they would help you. We have our global support centers across the geographies in the main business centers, and our support team follow the Sun model. That means you have support personnel to help you out 24/7. We have flexibility in choosing support option, which I would be covering in next slide: basic, standard, and premium. And you have access to analytics capabilities to have a deep insight into what's going on in your environment. You have flexibility to choose the support option, weekday basic, standard, and premium as per your business requirement. With premium, you have on-site support within 2 hours. In this slide, if I have to highlight one capability, it's a really high-track remote monitoring that takes care of 24/7 remote monitoring and troubleshooting. What it does is actually it continuously does the health check assessment, and if it finds any anomaly, it opens the ticket and someone gets on the work into investigating the issue and help you out. So John, you have been around for some time. I think you have used high-track monitoring in your previous life. You want to share thought about it?
Yeah, so I mean, this goes back to the build versus buy, and really the experience of what you're getting when you buy a true, fully hyper-converged system like UCP HC here. And HyTrack is HDS's phone home system. I worked with it. I was a consumer of it from a customer side and partner side. And that whole knowledge that, at 3 in the morning, if something goes down, someone else is watching it, is going to proactively dispatch people to handle that problem. That's a completely different, experience, as well as also the fact this is all one converged solution. Hitachi can monitor, the switching. They can monitor the host. They can monitor the individual drives. They've got full awareness of that. You've got full proactive support versus you've got 3 or 4 different vendors in your data center, each of which you have to do your own monitoring. You have to watch your alerts. You have to have someone manage that. And then you have to have someone on your side manage the calls to say, hey, I think something's down, manage the finger pointing. This is a completely different experience of having, one throat to choke, so to speak, as well as one person proactively helping you monitor your infrastructure.
Great. Thank you, John. So to sum it up, UCP HC is the smart choice for your data center implementation or your branch office implementation because it provides you scale in performance. It improves simplicity with advanced policy-based management integration with performance, efficiency, and availability, as John covered in detail. Leveraging industry standard component and space efficiency technologies, it brings down cost of ownership, TCO, significantly. And with native and optimized data protection capabilities, it brings down the risk to your business. Some of the next steps, you can contact HDS account manager or channel partner if you need more information. What we discussed, some of it, or reference architecture for use cases are available on hds.com. The web URL is on your screen, hds.com/hyperconverged. Some information is on, a lot of information is on VMware website also. There are some jointly published reference architecture. If you want more information around virtualization, HDS, VMware, cloud infrastructure, you can follow us. The Twitter handles are on your screen. Dinesh Singh 2004, lost signal. I could take up one more question which I have, then we can open it for the floor. Is the HDS DR solution using VMware Site Recovery Manager? Yes, it does use Site Recovery Manager for orchestrated recovery and also for your test run for DR capabilities. So we can open it up for Q&A now, Karen. You have any closing thought, John, before you open up for Q&A?
No, I mean my closing thought is just think of your infrastructure as a holistic problem, not necessarily a box of different components you have to piece together, and making sure you've got a partner who understands the challenges, not only the virtualization layer but also the rest of the data layer, be it object storage, be it file, unstructured, things like that. That's one thing that Hitachi brings to bear with this solution that I think is a really great story, as well as having that SPBM being able to seamlessly manage not only your hyperconverged but your existing traditional storage assets all in one interface is really nice.
Perfect. I will direct our attendees for any questions you'd like our speakers to answer before the conclusion of the webcast to please enter them now. If not, Dinesh and John, do you have any final thoughts you'd like to share with us before we close out?
It was a great session, and as John said, Hyperconverged is one part of the story. It nicely fits in the overall architecture with Hyperconverged, with converged, with traditional storage, and the policy-based management is what unifies it all together. And I think that would be all. If there is any question, otherwise, happy holidays to all of you, and thanks for joining us today.
I'll say my last thing on the way out, storagehub.vmware.com. There is a huge amount of content there. I know there's been a lot of questions around stretch clustering and specific use cases. Check that out. There's demos, there's videos, there's white papers, there's reference architectures. It's all at storagehub.vmware.com, not only for vSAN, but also SRM and our other storage components.
Yeah, I got one more question. Is Hitachi Command Suite used with this Hyperconverged product? No, because Hitachi Command Suite is specifically for VSPG and VSPF storage system, external storage system. UCP HC Hyperconverged solution leverages VMware vSAN, vCenter, and UCP Advisor for lifecycle management. There is another question. Please share some more white paper links for models. Okay. Yeah. David, if you can share the links. If you go on hds.com, which is on your screen, the vanity URL, hds.com/hyperconverged, it takes you to a web page that has a host of white papers, and you can also do a search. Yeah, and as a follow-up, someone from HDS can email you white papers on different use cases.
Perfect. Well, thank you both so much for this informative webcast. I think our attendees can all agree that we all learned something extremely valuable, and thank you so much for answering the questions provided by everyone. I would like to thank all of our attendees for joining us. As a reminder, you will receive an email directing you to the materials from today's webcast. And please make sure to complete the short online evaluation that pops up when you leave to let us know how today's session went. Thank you again for attending, and have a wonderful rest of your day.